Good day, Evan Snowman here again for Umhloko, Making a Difference. Today we're looking at analytical geometry lesson 7, looking at some more advanced examples coming from old exam papers. To start with, this interesting question, where we're being asked to find the domain and range of a circle whose equation is given, but there's no diagram. So we've got x squared minus x plus y squared plus 6y equals 11. And you may notice again that I'm leaving space to complete the square. So if this is coefficient minus 1, I need to halve it and square it. This coefficient is 6, so if I was to halve it and square it, and if I do that, I need to add a quarter to the right-hand side, and I need to add 9 to the right-hand side to keep the equality. What I then have is x minus a half squared plus y plus 3 squared equals 20 and 1/4, which I prefer to write as 81/4 because it makes it easier to see what we need to do, what we need for this question. And so now what I have is a circle whose center is at a half and minus 3, and whose radius is going to be 9/2 because 81/4 is 9/2 squared. So again, what I need you to understand is that if I was to draw a quick sketch of this idea, that if my circle center was at a half and minus 3 over here somewhere, the domain would be all the x values that are allowed. So in other words, left and right of this circle center. So 9/2 to the left and 9/2 to the right. Given that 9/2, some of you guys might be saying to me that you prefer that 9/2 is 4.5. So I need the values that are 9/2 to the left of a half. So therefore my domain will be x is greater than or equal to minus 4, or greater than or less than equal to a value that is 4.5 to the right of a half, and that will be 5. In the same way, my range will be 4.5 above or below this y value. So 4.5 above minus 3, or 4.5 below minus 3. Well, below minus 3 would be minus 7.5, and above minus 3 would be 1.5. And you can write that in separable notation, or you can write it in interval notation. So x is an element of minus 4, 5, square brackets. Okay, remember that x is an element of real numbers and y is an element of real numbers, is part of the notation. Okay, or y is an element, if I was continuing in separable notation, of minus 7.5 up to 1.5. Again, those of you who have got old-fashioned teachers would not be writing it as a mixed fraction, you'd be writing it as an improper fraction, and I would actually encourage that. Okay, so an interesting example coming from the idea of domain and range. Okay, again, we need to be flexible with our formats. We need to be able to complete the square quite comfortably, both on the x values and the y values, to get the graph into standard form, or the equation into standard form, so we can interpret it more easily. Okay, moving on to the next example. Again, we've got a circle given by a certain function, a certain equation. They don't give us the r value. Okay, surprise, surprise. Question A, the first question, they ask us to find the r value. We've got a tangent given by this line. Okay, and we are asked to find the equation of the tangent with a positive y-cut. Okay, so we need to do some work here. Again, as I said to you, being a bit more advanced question, we probably want to draw a quick drawing. Let's have a look at this. Okay, so having a quick look, we have got a circle centered at, we know that the circle center is going to be at 0 and 2. So it's 0 across and 2 up. So the circle center is on the y-axis. This graph has got a tangent given by minus 3x plus 22, so it's a graph that sits there somewhere. Okay, granted that my diagram is not being drawn to scale. Okay, and so here somewhere is this circle. Okay, may or may not touch the x-axis. I'm not sure about that yet, but what I do know is that it is centered at 0 and 2, and it is tangent to this line over there. What I therefore do know is that this radius will need to be at right angles to the tangent. And I know that this radius will go through um, will go through the circle center, but will also go through the circle and touch this line y equals 3x plus 22. So what I'm going to look at here is this idea that this tangent is the line y equals mx plus c, but if the gradient of the tangent is minus 3, then the gradient of the radius needs to be 1/3. So we got a third x plus c, and we know that goes to the point to the circle center, which is 0 and 2, which again, if we just think about it, means that the c value, which this graph must be 2. So y equals a third x plus 2. Okay, now we need to find, we've got the equation of the tangent, we've got the equation of the line, and we're trying to find the coordinates of r. So again, we need to follow on. There's a part two, there's a continuation to the sum. So we're looking for the intersection point of where these three things are equal. That will be the point of tangency. So in this case, we can't use the equation of the circle as we did in an example in a previous lesson. We are going to use the equations of the two lines. So a third of x minus 2 equals minus 3x plus 22. I'm going to make these things, I'm going to get rid of the fractions. So x minus 6 equals minus 9x plus 66. So I've now got 10x equals, okay, I just want to see if I didn't make a silly error here. 10x equals 72. So x equals 7.2. And as a result, again, I probably meant this to be a minus sign somewhere here. Just checking for minus sign errors because it feels like I may have made a minus sign error. The 6 and the 66. Okay, so I'm just checking my work. And again, I'm not seeing any errors, so I'm going to continue. As a result, y equals, we've got minus 3 times 7.2 plus 22, which equals minus 21.6. 21.6 plus 22. So the y value at this point of tangency is going to be 0.4. Okay, so what we now have is a point over here that is at 7.2, sorry, not a semicolon, but a comma, 7.2 and 0.4. Okay, and we got the point here, which is at 0 and 2. So we now need to find the length of the radius. And so we simply go and use the distance formula. Therefore, the length of the radius will be, equal to the change in x, which is 7.2 squared, plus the change in y, which in this case will be 1.6. What we have now is a question which I've seen in a couple of the old exam papers or similar ones to it. We now need to think about whether two circles will touch, intersect, or neither. And the key concept here is that if I had these two circles, let's just have a look here. Okay, this circle has got a radius, so let's call that R1, and this circle has got a radius, let's call it R2. What we now need to consider is that this length or distance between the two circle centers. If this distance is equal to R1 plus R2, exactly the right amount, the right length. That means that these two things are just touching each other. These two circles are effectively doing something like that. They are tangential. If the D value is larger than R1 plus R2, think that through. If the distance between the circles is too big, that means that these two circles will be pretty much like I have in the diagram on the left, that the distance between them will be larger, and it will be a case of neither. However, what if D was less than R1 plus R2? Well, then we would have a situation that looks as follows. These two things would be overlapping to one another, and they would therefore overlap, or we would say that they intersect one another. And so what I want to do here quickly is I want to look at how to go and solve this particular example. And so let's have a look. Okay, as always, I'd encourage you to draw a drawing. We've got a situation where we know that the one circle is centered at the origin. Okay, so let's have a look at this question. This one here, okay, it will be centered at the origin with a radius of 5. So again, let's just try and draw this one in. There is not the world's worst circle, maybe not the world's best circle, but not the world's worst circle. And a second one where we know that this thing here is centered at 7 and minus 8 with a radius of 10. So we know it's centered here at the point 7 and 8, 7 and minus 8 with a radius of 10. So this one has a radius of 5, and we're now trying to see if this circle here, what does it do with regards to the red circle? Does it cut? Does it not cut? What happens to it? You know, what is happening here at this point? Does it overlap? Does it meet? Does it just touch? And the key idea, as I said, is to look at the distance between the two circle centers. Okay, so that is the key to the sum. So we will look at the distance here, and the length, the distance between two circle centers is going to be the change in x. So we know that the one is going to be 7 squared plus 8 squared, which is 49 and 64, which will so the square root of 49 plus 64, 49 plus 64 equals 113, which is a little bit less than 11, 10 point, sorry, just quickly using the calculator to get the answer, 10.6. Okay, so we know that these two circle centers are 10.6 apart. What we realize? We realize that 10.6 is less than the 5 plus the 10, which equals 15. So therefore, these two circles do intersect. Okay. Now, what is interesting about these two circles is they will intersect at 2 points, and those 2 points will be on the circumference of both circles. So we can find this point of intersection by making the two circles equal each other. Okay. However, if we do make those two circles equal each other, what ends up happening is something which is quite interesting. Okay, so if we do try to find the point of intersection of these two circles, so now we know that these two circles do in fact intersect. And if we now try to find the point of intersection of these two circles, something really interesting happens. So let's have a look at that. Okay. So what I would now like to do is actually, I've answered that question about whether they are whether they do intersect. We now know that they do intersect. I now want to find the points of intersection between them. Okay. So question B, I want to find the points of intersection. Now, normally with points of intersection, you make the equations equal each other. And in this case, I've got x squared plus y squared equals 25, and the equation of x minus 7 squared plus y plus 8 squared equals 100. And again, what I'm going to choose to do in this case is I'm going to choose to write the second equation in expanded form. So x squared plus, excuse me, x squared minus 14x plus 49 equals, sorry, again, not equals, plus y squared plus 16y plus 64 equals 100. And I'm going to choose to take this equation and I'm going to choose to rewrite it as y squared equals 25 minus x squared. And when I put this into that equation, please note what happens. I will now have x squared minus 14x plus 49 plus 25 minus x squared, 25 minus x squared plus 16y plus 64 equals 100. These x squareds, unfortunately, not unfortunately, but perhaps unfortunately, will cancel out. And what I now have is minus 14x plus 49 plus 25 plus 16y plus 64 equals 100. Alternatively, 16y minus 14x equals, let me work this out, 64 plus 49 plus 25 equals 38. Okay, now, again, if you looked at this a little bit more closely, you'll see that this is the equation of a line y equals, take the 14 over, 7 over 8 x plus 19 over 8. And what you see is that you're not getting the equation of a point. This is equation of a line. And which line it might be, you might ask, and quite interestingly, it is the equation of this line here. It is the line that actually goes through those 2 points. Okay, the 2 points of intersection. It is not actually the points of intersection themselves, it's actually the equation of the line that goes through those 2 points of intersection. And for those of you who think about it, this line is going to end up being perpendicular to the line that joins the circle centers. And again, given that this point here was 0, 0, and the other point and the other circle center was at 7 minus 8, we would see that the gradient of this green line was going to be minus 8 over 7. So it's no surprise then that the gradient of the yellow line is 7 over 8 perpendicular to it. To get the actual points of intersection, you're going to have to do some more work. And what you'll now do is you'll throw this equation into x squared plus y squared equals 25. I'm not going to go through that right now, but what we now have is something along the lines of x squared plus 7 over 8x plus 19 over 8 squared equals 25. and we would have to work with those fractions and follow through. And again, it would not surprise us that we got two answers, one for the one point of intersection and one for the other point of intersection. Okay, everybody, thank you so much. This is the end of the chapter on analytical geometry. All the best for your exams in this topic. Thank you.